students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as determinants. Let's see this. How do we solve determinants? What is determinant? It is nothing but set of numbers 1, 2, 3, 4 which is arranged in the form of rows and columns. How do I know that it is determinants? You will have this modulus sign on either side that will indicate that these are determinants. Right? I need to find the value of this determinant. How do I find the value of the determinant? The diagonal running downwards is called as the principal diagonal and the other one is called as the other diagonal. The value of the determinant is product of the principal diagonal minus the other diagonal. That means this is going to be 1 into 4 minus 3 into 2. Product of the principal diagonal minus the other diagonal. Product of the principal diagonal minus the other diagonal. So this is 4 minus 6 minus 2. Next, let's see the next sum. X plus 3, x plus 2, 3x minus 6, x minus 2 is 0. Find x. Right? How do I solve this, guys? It is product of principal diagonal minus the other diagonal. That means this will be 2x plus 3 into x minus 2 minus 3x minus 6 into x plus 2 should give you 0. Product of principal diagonal minus the other diagonal. Open the bracket, that means 2x has to be multiplied with whole thing. So this will be 2x square minus 4x plus 3x minus 6 minus. Now multiply 3x with the second bracket. So this will be 3x square plus 6x minus 6x minus 12 is 0. So this will be 2x square minus 4x plus 3x is minus x minus 6. Open the bracket, minus 3x square plus 6x minus 6x gone, minus into minus, plus 12 is 0. So in that case this is going to be 2x square minus 3x square minus x square minus x plus 6 is 0. But we know that in a quadratic equation, the square term can never be negative. So multiply by minus 1. If I multiply by minus 1, I'll get x square plus x minus 6 is 0. Factorize this. Factors of 6 are 3 and 2. So this is x square plus 3x minus 2x minus 6 is 0. X plus 3 minus 2 x plus 3 is 0, common bracket x plus 3, uncommon bracket x minus 2, either x plus 3 is 0, therefore x is equal to minus 3, or x minus 2 is 0, therefore x is equal to 2. Right? Next, let's see another sum, guys. Now this was how you would solve a 2 by 2 matrix. Right? How would you solve a 3 by 3 matrix? Let's see this. How would I solve a 3 by 3 matrix? Right? Now for a 3 by 3 matrix, I need to write, let's see this. This is 1, 2, a matrix or determinant. 2, 3, 4, 3, 4, 5. Right? We've seen how to solve a 2 by 2 determinant. Now let's see how do we solve a 3 by 3 determinant. 3 by 3 means there are 3 rows and there are 3 columns, right? Now, guys, can you please see this? What you have to do is take the first element of the first row. If I'm taking the first element of the first row, that means I cannot take the first row and the first column. The element that I take, I cannot take that particular row and that particular column. That means that leaves me with 3, 4, 4, 5. If I cannot take the first row and the first column, what remains with me, the numbers that remain with me are 3, 4, 4, 5 minus. Why minus? That's a part of the formula. Take the second element of the first row. Take the second element of the first row. Now if I am taking 2, that means I cannot take the first row and the second column. If I leave the first row and the second column, what remains is 2, 3, 4, 5. plus, why plus? That's a part of the formula. Take the third element of the first row, right? Once I take the third element of the first row, that means I cannot take the first row and the third column. That means I will have 2, 3, 3, 4. Now how do I solve this? Guys, I already explained to you how to solve a 2 by 2 determinant. It is product of principal diagonal minus the other diagonal. That means this is going to be 5 3s are 15 minus 16 minus 2, 5 2s are 10 minus 12 plus 3, 4 2s are 8 minus 9. So this is going to be minus 1 minus 2 into minus 2 plus 3 into minus 1 minus 1 plus 4 minus 3, that will be 0. That's how you would solve a 3 by 3 determinant. Next, let's see another sum, guys. A, B, C, B, C, A, C, A, B. Right? I just explained this to you how to do a 3 by 3 determinant. Take the first element of the first row. So if I take the first element of the first row, I cannot take the first row and the first column. That means this will be CAAB minus B. Why minus? Minus is a part of the formula. Take the second element of the first row, right? That means now I cannot take the first row and the second column. If I cannot take the first row and the second column, then this will be BCAB plus C. Why plus? That's a part of the formula, right? I'm taking C. If I take C, I cannot take the first row and the third column. That means this will be BCCA. So in that case, this will be A. How do I solve a 2 by 2 determinant? Product of the principal diagonal minus the other diagonal. That means this will be BC minus A square minus B, B square minus AC and plus C. This is AB plus C square. Minus C square, sorry. Product of principal diagonal minus other diagonal. So this is going to be ABC minus AQ. When I open the bracket, I have to multiply A with both the terms. Minus B cube, minus into minus plus ABC plus ABC minus C cube. So this is going to be ABC plus ABC plus ABC. Thrice ABC minus A cube minus B cube minus C cube. That will be the answer for that, right? Next, let's move on to the next exercise. Five x minus 4y is 120. 4x minus 5y is 60. Solve using Cramer's rule. Right? Let's see how do we solve this using Cramer's rule. Now, when you have to solve using Cramer's rule, make sure that the constants are on the right hand side. Make sure that the constants are on the right hand side. You first find out D. How do I find out D? Write the coefficients of x one below the other. Write the coefficients of x one below the other. Then write the coefficients of y one below the other. Minus 4, minus 5. Write the coefficients of x one below the other. Write the coefficients of y one below the other. This is product of principal diagonal 5 minus the other diagonal. So this is minus 25 plus 16, that is minus 9. Then you have to find out dx. How do I find out dx? Replace the column containing the coefficients of x. Replace the column containing the coefficients of x with right hand side. So whatever were the numbers with x, replace that particular column with the right hand side. So instead of 5 and 4, I'll write 120 and 60. Y will be as it is, minus 4, minus 5. Right? So this is going to be, how do I solve this? Product of principal diagonal minus other diagonal. So minus 600 minus 6 4s are 24, 240. So this is minus 600 plus 240, that's minus 360. Right? Next, dy. How do I find out dy? Again, look at your determinant d. In this, replace the coefficients of y with the right hand side. Replace the coefficients of y with right hand side. So in that case, x coefficients you will write as it is. Y coefficients you will write as 120 and 60. Right? So this is going to be, how do I solve this? This is product of principal diagonal minus other diagonal. 6 5s are 30 minus 480, that's minus 180. Once you have this, then you apply Kramer's rule. By Kramer's rule, you can say x is dx upon d and y is dy upon d. So x is going to be dx is minus 360 upon d minus 940, and y is dy upon d minus 180 upon d minus 9. So minus minus 120. So x is going to be equal to 40 and y is going to be equal to 20. Fine, do we get this in here? Now, this particular sum could have been framed this way also. See, I'll frame the sum slightly differently. Find the point of intersection. Find the point of intersection of the lines. Find the point of intersection of the lines. 2x minus 5y plus 12 is 0. And 5x minus 3y minus 8 is 0, right? So if they were to give you the sum this way, then I can say that the two equations are 2x minus 5y is minus 12. The plus 12 goes on the other side, becomes minus 12. Similarly, 5x minus 3y is 8. Once you have this, then you can apply Kramer's rule. I can find out d first. How do I find out d? What you do is write the x coefficients one below the other, y coefficients one below the other. Product of principal diagonal minus the other diagonal. So minus 6 plus 25, that's 19. Right? Next, then you find out dx. How do you find out dx, guys? Replace the x coefficients with the right hand side. So minus 12, 8, minus 5, minus 3. Leave the y coefficients as it is. So this is going to be 36 minus 40. So this is going to be 36 plus 40, that is 76. Right? dy. In your determinant d, replace the y coefficients with the right hand side. So this is 2, 5 and this is minus 12, 8. So this is going to be 16, product of principal diagonal minus other diagonal. This is 60, minus 60. So 16 plus 60, that's 76. Then I can apply Kramer's rule. Kramer's rule says that x is equal to dx upon d. Dx is 76 upon 19, that is 4, and y is equal to dy upon d, that is again 76 upon 19, which is 4. Therefore I can say that point of intersection is 4, 4. That's how you get your point of intersection. Next, let's move on ahead, people. Now suppose if they gave you a sum like this. 5 upon x minus 1 plus 8 upon y plus 1 is 9, and 4 upon x minus 1 plus y 6 upon y plus 1 is 7. You have to solve this using Kramer's rule. So in this case, I have a denominator. How do I get rid of the denominator? You will say let 1 upon x minus 1 be equal to capital X and 1 upon y plus 1 be equal to capital Y. In that case, if I substitute this, then my equations will become 5 upon x minus 1 can be written as 5x, because 1 upon x minus 1 I have assumed as capital X, plus 8y is 9. 1 upon y plus 1 I have assumed as y, right? Similarly, this is going to be 4x plus 6y is 7. Once I have the equation this way, then I can find out d first. How do I find out d? Write the coefficients of x one below the other, write the coefficients of y one below the other. This is 6 5s are 30, 4 8s are 32, minus 2. Next, find out dx. How do I find out dx? Substitute the x coefficients with the right hand side. So that means this will be 9 7 8 6, 54, principal diagonal minus the other diagonal, 56 minus 2 dy, right? In your determinant d, substitute the y coefficients with the right hand side. So this is 5 4 9 7. This is 35 minus 36, that's minus 1. Now, let's apply Kramer's rule. If I apply Kramer's rule, then I can say x is equal to dx upon d, right? Dx is minus 2 upon d, minus 2. So I'll get capital X is equal to 1. But what is the value of capital X? The value of capital X is 1 upon x minus 1. So I will substitute the value of capital X as 1 upon x minus 1 is equal to 1. Cross multiply. So I'll get 1 is equal to x minus 1. So x is equal to 2. Similarly, I can say y is equal to dy upon d. Dy is minus 1. D is minus 2. Right? So in that case, now I'll get therefore y is equal to 1 upon 2. But what is the value of capital Y? Capital Y is nothing but 1 upon y plus 1. So 1 upon y plus 1 is 1 upon 2. Cross multiply, so I'll get 2 is equal to y plus 1. Take 1 on the other side, 2 minus 1. 1 is equal to y. So you will get your value of x and y. Right? Do we get this? Let's see another similar sum like this. 1 upon 2 raised to x plus 2 upon 3 raised to y is equal to 10, and 3 upon 2 raised to x minus 5 upon 3 raised to y is equal to minus 3. Right? Since I have a denominator, I am going to substitute this. So you will say let 1 upon 2 raised to x be equal to capital X and 1 upon 3 raised to y be equal to capital Y. In which case my equations now will become, this particular equation will become x plus 2y is 10. 1 into x will give you x. 2, 1 upon 3 raised to y is y. So x plus 2y is equal to 10. Similarly, this is going to be 3x minus 5y is equal to minus 3. Right? Now let's find out d first. How do you find out d? Write the coefficients of x one below the other. Write the coefficients of y one below the other. Right? So in that case, this is going to be principal diagonal minus the other diagonal. So this is minus 5, minus 6, minus 11. Next, dx. How do I find out dx? Substitute the coefficients of x with right hand side. So if I substitute coefficients of x with right hand side, that means instead of 1 and 3 I will write 10 and minus 3, 2 and 5. This is 50 minus 6, right?
It's minus 50 plus 6.
Yeah,
Minus 50
minus
plus
50
6.
plus
6 is minus
2
50.
minus 5.
Yeah, 2 minus
5 is with negative.
This is minus 2 and minus 5. So in that case, this is going to be minus 50
Plus 6.
minus of minus 6. So this is minus 50 plus 6, that's minus 44. Right? Once you have this, then you can find out dy. How do I get dy? Substitute the y coefficients with the right hand side. So this is going to be 1, 3, and instead of y, I'm going to write 10 and minus 3. So this is going to be minus 3 and minus 30. So that's minus 33. Now apply Kramer's rule. By Kramer's rule, I can say x is equal to dx upon d. X, what's the value of x? We found out the value of x to be 1 upon 2 raised to x is dx. Dx is minus 44 upon d. D is minus 11. Right? 2 raised to x. When I take it in the numerator, will become 2 raised to minus x. Right? Minus minus gets cancelled, 11 and 4. So I'll get 2 raised to minus x. 4 can be written as 2 square. 4 can be written as 2 square. Now since the bases are same, I can equate the indices. If I equate the indices, I'll get minus x is equal to 2. Therefore x is equal to minus 2. Similarly, I can find out y. Y is equal to dy upon d by Kramer's rule. Capital Y you had assumed as 1 upon 3 raised to y is dy minus 33 upon minus 11. 3 raised to y. When I take it in the numerator, the sign of the indice changes. So this will become 3 raised to minus y is 3. Minus and minus gets cancelled. When there is nothing in the indice, you assume the indice to be 1. When there is nothing in the indice, you assume the indice to be 1. Since the bases are same, I will equate the indices. So minus y is equal to 1. So y is equal to minus 1. Now I could do the same thing with 3 variables also. I could use Kramer's rule with 3 variables also. I could say that x plus y plus 2z is 9. X plus 3y plus 2z is 13. 3x plus y plus 3z is 14. Right? Now, if you had a sum like this, you could solve this again using Kramer's rule. Right? First thing that you need to do is you need to find out d. How would I find out d? Write all the x coefficients one below the other. 1, 1, 3. Write y coefficients one below the other. 1, 3, 1. Z coefficients one below the other. 2, 2, 3. Right? Now I have already explained to you how to solve a 3 by 3 determinant. Take the first element of the first row. 1 is the first element of the first row. If I take 1, that means I cannot take the first row and the first column. So that leaves me with 3, 2, 1, 3. Minus, take the second element of the first row. That means I cannot take the first row and the second column. So this is going to be 1, 3, 2, 3. Plus, take the third element of the first row. That means I cannot take the first row and the third column. So this is 1, 3, 3, 1. So in that case, this is going to be equal to 1, 9 minus 2 minus 1, 3 minus 6 plus 2, 1 minus 9, 7 minus 1 minus 3 plus 2 minus 8, 7 plus 3 minus 16. So this is going to be minus 6, right? Once you have minus 6 right? Then you find out dx. How do you find out dx? Substitute the x column, guys, substitute the x column with the right hand side. So this will be 9, 13, 14, 1, 3, 1, 2, 2, 3, right? So this can be written as, take the first element of the first row. I cannot take the first row in the first column, so 3, 1, 2, 3, minus, take the second element of the first row. I cannot take the first row and the second column, so 13, 14, 2, 3, plus 2. Take the third element of the first row. I cannot take the first row in the third column, 13, 14, 3, 1. So this is going to be 9. 3 3s are 9 minus 2, 39 minus 28 plus 2, 13, 42. Principal diagonal minus the other diagonal I have done. This is 9, this is 7. 9 7s are 63 minus 1, 28, 38, 39 plus 2.
68. 2 into that is 16.
Wait, I'll just do this.
Minus 13.
This is minus 34.
So
42. This
14
is
please, it's 42.
right. 42, 32. This is 29. Minus 29. Right? This is 63 minus 11 minus 9 2s are 18, 2 2s are 4 and 1 5. Right? This is 63, 68, 69
Minus 6.
minus 6. Right? Once I get dx, then I need to find out dy. How will I find out dy? In your determinant d, substitute the y coefficients with the right hand side. If I substitute the y coefficients with right hand side, I'll get dy is equal to 113, and this is going to be 9, 13, 14, and next is going to be 2, 2, 3. So this is going to be 1. Now, if I take the first element of the first row, this is 13, 14, 2, 3, minus 9. Second element of the first row. So in that case, you will have 1, 3, 2, 3. I cannot take the first row and the second column, plus 2. Third element of the first row. I cannot take the first row and the third column. So this is 1, 3, 13, 14. So this is going to be 1, 39 minus 28. This is 3 minus 6 plus 2, 14 minus 39. Right? So this is going to be 28, 38, 39. Right? Minus 9 minus 3 plus 2, 39, 29, 25. Minus 25. Now this is going to be 11 minus into minus plus 27 minus 50, 27, 37, 38 minus 50, which is minus 12. Then you find out dz. How do I find out dz? In your determinant d, substitute the z coefficients with the right hand side. So in that case, this will be 113, 131 and 9, 13, 14. Right? So in that case, this will be first element of the first row. So this will be 3, 1, 13, 14. Second element of the first row, minus 1. Wait, I'll just write this again. 1. If I take the first element of the first row, I cannot take the first row and the first column. So 3, 1, 13, 14. Minus 1. Second element of the first row. I cannot take the first row and the second column. So 1, 3, 13, 14 plus 9, third element of the first row. I can now take the first row and the third column. So 1, 3, 3, 1. So this is going to be 42 minus 13 minus 1, 14 minus 39 plus 9, 1 minus 9. So in that case this is 42, 32, 29 minus 1 or minus, this is 25 minus 25, right, plus 9, this is minus 8, right. So this is 29 plus 25 minus 72, 49, 54, 54 minus 72, 64, 74 minus 18, right. Now I can apply Kramer's rule. If I apply Kramer's rule, I can say x is equal to dx upon d. Dx you found out was minus 6 upon d you found out is again minus 6. So 1, y is dy upon d. dy you found out as minus 12 upon minus 6, that's 2. And z is dz upon d. dz you found out as minus 18 upon minus 6, that's going to be 3. Let's see another similar sum like this. What if a particular variable is missing? This was 9th. Let's see another sum. Suppose if I have x plus 2y plus z. X plus 2y plus z is 7. 3x plus z is minus 5. 2y plus z is 9. Now in the second equation variable y is missing. In the third equation variable x is missing. How do I solve this? D will be 1, 3. Since x is missing, I'm going to assume this to be 0. Then 2, y is missing, I'm going to assume that to be 0. So 2, 0, 2, 1, 1, 1. Right? Now, this is going to be 1. This is 0, 2, 1, 1. Minus 2, 3, 0, 1, 1. Plus 1. 3, 0, 0, 2. So in that case this is 1, 0 minus 2, minus 2, 3 minus 0, plus 6 minus 0, right? So this is going to be minus 2, minus 6, plus 6. So this is going to be minus 2, right? Plus 6 minus 6 gets cancelled. Next, let's find out dx. How do I find out dx? To find out dx, I need to substitute the x coefficients with the right hand side. So this is going to be 7 minus 5, 9, 2, 0, 2, 1, 1, 1. Right? This is 7, 0, 2, 1, 1, minus 2, minus 5, 9, 1, 1, plus 1, minus 5, 9, 0, 2. So in that case this will be 7, 0 minus 2, right, minus 2, minus 5, minus 9, plus 1, minus 10, minus 0, right. So in that case this is minus 14, this is 9, 10, 14, minus 14, minus 2, plus 28, minus 10. This is minus 24 plus 28. Excuse me. So this is going to be 4. Once I have dx, then I can similarly find out dy. How do I find out dy? In the determinant d, substitute the coefficients of y with the right hand side. So this is going to be 1, 3, 0. 7 minus 5, 9 and 1, 1, 1. This is 1. If I write 1 here, this is minus 5, 9, 1, 1. Right? This is minus 7. So in that case 3011 plus 1, 30 minus 5 9. So this will be 1 minus 5 minus 9 minus 7. 3 minus 0 plus 1. 27 minus 0, 9, 14. This is going to be minus 14 minus 21 plus 27. 14, 21, 31, 35 minus 35 plus 27, that's minus 8. Right? Then similarly I can find out dz. How do I find out dz? In the determinant d, substitute the coefficients of z with right hand side. So this is 130, 202, and instead of 111 I'll write 7 minus 5 9. So this is 102 minus 5 9 minus 230 minus 5 9 plus 7 3002. So this is one principal diagonal minus the other diagonal. So 0 minus of minus plus 10 minus 2. 27 minus 0 plus 7. 6 minus 0. So this is 10 minus 54 plus 42. So this is going to be 52 minus 54, that's minus 2. Now I could apply Kramer's rule. By Kramer's rule, I can say that x is equal to dx upon d. Dx upon d. Dx is 4 upon minus 2. So that's minus 2. Y is dy upon d. Minus 8 upon minus 2. That's 4. And z is equal to dz upon d. Minus 2 upon minus 2. That's 1. Right? Okay. We'll stop this here for the day. Thank you very much.